If you've ever flown on a plane, you've probably noticed that the windows are round. You'll never see square windows on airplanes. But when cars, buses, buildings have square windows, why are airplanes' windows especially round? The reason for this is not beauty or design. It is completely scientific and safety related. So today we will see what is the reason. Did you know that unlike the atmospheric pressure at sea level, when an airplane is flying high in the sky, the outside air pressure is very low? However, in order for us to breathe comfortably inside the plane, a higher air pressure is artificially maintained inside. This is where a big problem begins. That is, the air pressure inside the plane increases, but the atmospheric pressure outside the plane is low. So, due to the difference in air pressure inside the plane and the air pressure outside, a lot of pressure is exerted on the windows from inside the plane. In this way, a force of 5,650 newtons is exerted on one window. That means that a weight of about 577 kilograms is pressed on one window. So you can imagine how much pressure this is. So, you're probably wondering why the windows do not break even though window feels such a lot of pressure. There are several reasons why the windows do not break in this way. Let's look at them one by one. Number 1. The shape of the windows is round. When you go up, the internal pressure of the plane is greater than the external pressure. This pressure difference affects the window. If planes have square windows, the stress can be focused on the corners, which can lead to problems like cracks or structural failure. The engineering solution to this was to install rounded oval windows. Since round windows have no corners, the pressure stress is distributed evenly. Number 2. Presence of a special type of glass. Aircraft windows are primarily constructed from advanced, high-performance, and lightweight materials designed to withstand immense pressure differences, temperature fluctuations, and structural stress, rather than standard glass. Instead of steel windows, most aircraft use polycarbonate. This is a strong, very difficult to break material. Number 3. Laminated glass. Aircraft window glass is multi-layered laminated glass. This strengthens the glass and reduces the risk of cracks. There are 3 layers in a glass. 1. Outer pane, structural, the thickest layer, bearing the brunt of cabin pressurization and external forces. 2. Middle pane, back up, a safety layer that takes over if the outer pane fails, also contains the bleed hole. Bleed hole is a small hole in the glass. It has many benefits. A pressure regulation. The hole equalizes air pressure between the inner and outer window panes, allowing the outer pane to handle the significant pressure difference at high altitudes. Safety barrier. It ensures that if the outer structural pane fails, the middle pane can take over as the primary load-bearing surface, preventing a catastrophic failure. Moisture control. It releases moisture from the sealed gap between panes, preventing condensation or frost buildup that would obscure the view. The 3rd layer is the inner pane, scratch protection, the thinnest layer, protecting the other panes from passengers and providing a touchable surface. Number 4. Plug design. The outer pane is wedge-shaped and is attached from the inside, using cabin pressure to seal it tightly to the fuselage, like a plug. We've talked about the reasons why airplane windows are round, but I think you need to ask another question. That's why cockpit windows are not round. Let's see what it is. Here's why cockpit windows are not perfectly round. Strengthened structure. Cockpit windows are built to withstand many high forces, including bird strikes and strong wind pressure. They are often 10 to 12 times thicker than cabin windows, and their frames are heavily reinforced to handle stress, allowing them to be used without failure at sharp corners. Visibility requirements. Pilots need a wide, clear, and undistorted view of other aircraft, terrain, and runways. A small, perfectly round window will severely limit visibility compared to a larger, more rectangular one. Design trade-off. The corners of cockpit windows are still typically rounded rather than sharp 90-degree corners, but they are not perfectly round. This provides a balance between structural strength and the required visibility. Now let's look at how these windows are manufactured. 1. Material selection and preparation. Here, a strong, transparent, and lightweight acrylic is selected. The acrylic is then heated and stretched, a process that improves its resistance to warping, cracking, and chemical exposure. 2. Layer fabrication. A typical passenger window consists of 3 distinct layers. 3. The bleed hole. Integration. A critical step in the manufacturing of the middle pane is drilling a tiny hole, often called a breather or bleed hole. 4. Shaping and forming. Here, acrylic sheets are cut into the exact, usually oval, shape of the window frame. The acrylic is then heated until it is smooth and formed into the precise, slightly curved shape needed to be flush with the aircraft fuselage. 5. UV and scratch resistance coating. Glass is coated with scratch-resistant layers to withstand the wear and tear of thousands of passengers. In modern aircraft, such as the Boeing 787, layers of electrochromic gel are added that allow the window to be electrically darkened. 6. Assembly and sealing. The windows are sealed, ensuring that they are properly aligned and airtight. Final inspection. Window units undergo rigorous quality control to check for visual clarity, strength, and structural integrity. 7. Installing glass in the window inside the fuselage. So now you know why that airplane windows are round. So I hope you learned something new from this video. If you like this video, please like and subscribe. There are more videos like this on my YouTube channel.